Hello my friends, welcome again to my video channel. Today we will start a new project. I think it's a small summer project, not so much work. Our local radio club got a Kenwood TS130S and a digital frequency controller DFC230. It's from an estate, and the relatives of the old man gave it to our local radio club and said, take it, do what you want. Well, our intention is to use it for newcomers, maybe for some portable applications, but in general we have other transceivers for this purpose. I took it home to check it whether it's okay. In the moment when I make this footage, I don't know what the situation is. I didn't try to switch it on. I will do it very carefully. The documentation is available, service manual of the transceiver and the schematic also for the DFC. More I don't know. The only thing what I smell is a little bit smoke. The previous owner was obviously a smoker, so some cleaning is necessary. There's also a lot of dust, dirt, fingerprints. That's always necessary with old gear. Maybe switching contacts and relays have to be cleaned. Maybe partially a realignment, I don't know. Don't talk so much. Let's start. For a first check, I will connect the transceiver to a power supply DC. I use a regulated power supply starting with 0 volt and current limited. I will set it to approximately 2 amps. A small dummy load just to prevent the HF amplifier from oscillation, self-oscillation. An open output can sometimes be a little bit dangerous. In general, these transceivers have no problem with an open output, but we do not know. And when I touch the PTT, then there should be a load, of course. Well, I will increase the voltage and see what happens. The transceiver is switched on. Receive mode, SSB. Band is, the knob is loose, I think it is 7, 10, 14 megahertz, not important. Microphone, carrier 0, RF gain fully, clockwise, AF gain, counterclockwise, width is off, noise blanker, all knobs are off. Okay, now I will start increasing the voltage and have a look at the ammeter. 5 volt, 8 volt, 14 megahertz, 13.6, nice. 10 megahertz, scale is at 300, 200. I first increase the voltage. Okay, now it's okay, 10 megahertz. Maybe the PLL had a problem. 12.13 volt. Current is 0.75 amps. It's 100, okay, that's okay. 14. Maybe the PLL had a problem with the low operation voltage. 18, 21. I have to fix the knob. Contact problems. 24, 28. Has to be cleaned. 3.5. That's it. Is there a calibrator inside? $25 kilohertz. Don't see. Interesting. Okay. There is some life inside. Well, here's the calibrator. It's connected to the microphone. Gain when it is set. Microphone gain down to 0. Then we have a calibrator. Each 25 kilohertz. 300. 25. Here it can be switched off. Well, at the first check it's okay, besides some contact problems, switch problems. So I will try to check the transmit function. A first check of the transmit section. I connected a dummy load. This is a power meter, 200 watt full scale, the 20, 40, 60, 80, 100 watt. Connected to a power supply of 13.8 volt up to 30 amps. That's sufficient. Specification says power input 160 watt DC for CW operation. It's a little bit more than 12, 13 amps. I have the box on. This is 80 watt output power on the 3.8 megahertz. That is okay. 7 megahertz. Only 20 watt output. But I think this is a consequence of the bad switch. 10 megahertz. Nothing. Suddenly power. Let's go to 29. Oh, noise. Okay, I see. First thing to do, what I have is to clean all contacts, pots, clean it outside, maybe also clean it inside. In general it works. I will do now a short test of the digital part, of the digital frequency controller, just to see what's going on. You may ask why I didn't check the SSB in the moment, because the microphone here has 8 pins, the input here has 4 pins, but the DFC has a microphone connection, 4 pins, and here we have the 8 pins, so I need the digital frequency controller to operate SSB with this connector. And now first thing I see, damaged cable. The braid is obviously still existing a little bit, so I have to be careful. This has to be repaired. The DFC is connected on the rear side of the transceiver. Here I can set whether it works in receive or in transmit or in both modes. I'm in the receive mode in the moment. This calibrator is switched on. (23.4, 23.4, 25. I can go to 50. That's okay. When I go back, then I can use the internal VFO. The S-meter deflection should be a little bit higher, I think. Maybe it's a problem with it, with this knob here. Also, the sensitivity also may suffer when the contacts are bad in the band switch, not only the output power. And now I will do a short check of the SSB mode. Test. 14 megahertz, processor is on, microphone gain fully clockwise, so there's some output. Without processor it's also okay. On 10 meter band, 28 megahertz. Nearly nothing. Okay, I think it's all related to this bad knob switch. In general, it seems to work. Well, now a little bit more power. There's a reverse mode. This is now a lower sideband on 10 meter. Also seems to work. The knobs are all removed. They can be slipped off. No set screws except the knob for the VFO. There's one set screw. Then the knob can be taken off. Bottom side looks rather clean. We have all 3 filters installed. That's good. According to the manual and to the marking of the owner, we have an SSB filter 2.4 kilohertz at 6 dB. This one has 1.8 kilohertz at 6 dB, and this is a 500 hertz filter at 6 dB. The 270 hertz filter is not equipped. We have here the the white one, 500 hertz. That's okay. The rest looks very pristine. Top side, not so nice. A lot of dust in this region. And this is a region where we have a perforation. That's the original location. And this grill, this perforation here, lets the dust in. And this looks ugly. I'll do a quick test with a ultraviolet lamp, whether I can see any signs of other dirt. But it is obviously nothing else in, no piss or so. It's only dust. Okay, this side, of course, I don't know how good you can see it in the camera, but this looks also rather clean. But here we have to remove the dust. This is a bigger job, and I will fetch a brush, soft brush, and a vacuum cleaner. To remove the front panel, it's necessary to unscrew these 2 nuts, one here and one here. The other nuts are not fixing the panel, and these 4 screws for the VFO, and then the whole unit can be flipped out. And as I see, we have to be careful. There's a plug which we can unplug. This wire can be unscrewed. These are the 2 LEDs for, I think, for the read indication and for VFO operation, or fixed and VFO also. This can be unscrewed and then it can be taken out easily. The disassembly is done. The front panel is okay, as I see. There's a small damage, but it's not important. Can be cleaned, but in general it looks okay. This is a VFO unit, that's also okay. The lamp is good, but I will replace this lamp by a white LED. Here we have the green rubber. It's like a small hose or so where the LED fits in, and then it gets green. I will take a maybe also green one. I will check it. What is better? Mechanic is okay. It is not sticky. It is smooth and silky as it should be. Be careful when cleaning this. Best is not to clean it because the printing is very old, and the danger to damage something is very high. Don't touch it as long as it is not necessary. Only use a soft brush, some very soft paper also, but in general it is not necessary. I would do nothing. It's okay. I will remove also the protection of the display, 2 screws. Here the instrument has a bad bulb. There's also the same bulb, but it is dark as I've seen. So I will take it out and replace it also with a white LED or a green one. I see what is foreseen in the color of the rubber. Clean the switches, the contacts, pots. Now it is accessible. Yes. Now I found out the reason for the loose knob for the band switch. It's not a knob. We have here fixing screws, here, and also on this gear, here and here. They were a little bit loose, especially here on this coupler, this coupling. I retightened them. I had to remove the front panel a little bit to have better access, and also to get better access to the pots for cleaning. It's easier when the front panel is a little bit moved. Here I found a wire hanging in the air. First I was a little bit surprised, but then after studying the manual I found there is a connection to block the, in those days, new WARC bands against transmit. It comes from 3 diodes and is fed to the driver stage. Anyway, here's a pin, counter pin for this. And this prevents transmitting on these new bands. Meanwhile, transmitting is permitted, so someone unplugged it. In other literature, it's simply recommended to cut this brown wire, but to unplug is a little bit more convenient when there is a plug. This is only the reason to have the new WARC bands active. Okay, next step will be I remove the old incandescent bulbs. One, and where's the second one? Here is it for the meter. These 2 I will replace by white LEDs. I will try it first with white LEDs and see what happens. This is a first test with a white LED and this green bag. It's silicone, I think, and it is greenish. The white LED can be squeezed in rather easily, and together with this greenish silicone bag it produces such a color. I think it's nice. It's okay. It's obviously very close to the original color. I will do this for the VFO and also for the meter. For the meter here, where we have this cover, and this bag is then, where is it? Here it is. Can be fixed. Will be fixed in this way, and then we have the illumination for the meter also. A standard trick: use a sandpaper to roughen the lens, because each LED or many LEDs have a lens on the top, and this lens always creates only a small spot. To avoid this, remove the lens. Okay, that's it. With this little trick we have a broad illumination, not a spot, in the instrument, in the meter, so that's okay now. By the way, I'm using the nominal current. It's 20 milliamps for this diode, for these LEDs, with a supply voltage of 13 volt and a voltage drop of approximately 3 volt. I use 560 ohms. That's okay. But before I reinstall the VFO, I will open this case and clean the capacitor, the contacts inside. I fear the grease dried out over the years. I didn't see actually any problems when I tuned it, when I made some tests, but I think there's a danger that in the future this will harden out, and also this gear would be happy to be cleaned a little bit, and it also would accept a drop of oil. This is an inside view. Here we have the capacitor, and there are two contacts. One is here and the other one is on the opposite side where the ball bearing is. It looks rather clean. I will use some gasoline or alcohol to clean and remove the residues, but in general the contact seems to be okay, but some cleaning is always good. One method is to use a small piece of blotting paper, use the slot here on this side, and then turn the capacitor so the blotting paper is squeezed in. And then you can get out some dirt. You do it from the other side also. Same way. And then here. To lubricate the capacitor, I use some oil with some graphite inside. It's a machinery oil for everything and nothing. But it's graphite inside, and graphite is always good. It's a little bit conductive, and I think it gives a long time stability. Only a small drop to the tip of a screwdriver. Same on the other side. And turn it around. The ball bearing also accepts a drop of oil. Same principle. Not too much. A drop is sufficient. Same for the gear. There's a second drop acceptable. Okay, that's it. Before I continue and install the front, I will undo a modification. This fuse is not original, and there is a wiring. This white wire comes from here, connected to the switch. It's a positive 13 volt supply, and the other end goes to, it goes to, the Oscar goes to the microphone connector. Someone added a supply of 13 volt to the microphone connector. I don't know what for. Maybe for a speech processor, preamplifier, I don't know. I will undo this modification, and all 4 pins are used, so I'm looking now which pin was removed, or which wire was removed from which pin, to In the manual terms, there are some traces of modifications. The remote connector pin 7 has plus 13.8 volt, but we don't talk about the remote connector. It's the microphone connector. In the digital frequency controller there's also something modified. Microphone connector, it's the 8-pin one. Pin 5 is a red connection. So switch is a PDT maybe, and the relay, transmit relay, standby relay. Okay, I have to look for some modifications. Not so nice. Here is nothing shown on the microphone connector. Well, let's undo it. The additional wires are out. The fuse holder also, it was glued. By the way, the fuse is blown. There's 1 amp. This will happen. If there is 13 volt on one of these pins, if a microphone connector is not perfectly suited, or the outside of the connector may get in contact here with these pins, or a screwdriver, whatever happens, it is not a good idea to have 13 volt here. And if you need 13 volt here, please use a current limitation. For example, a voltage regulator, 9 volt, limited to 100 or 200 milliamps or so. You don't need power here, only some milliamps for an amplifier. Well, now I will look for the modification here, because the arrangement of the pins is not okay, I think. The front panel and all knobs are in place again. The 2 LEDs are looking good. I think it's acceptable. These are white LEDs together with a greenish silicon tube they are in. They are producing this color. I think it's very close to the original one. Now we have no problems with the band switch. There are the D10 positions. The knob is stable now. It was not the knob, it was the gear. But as we see, we have stable frequency now. The reception of the side tone. The S meter reacts a little bit weak, I think, for this. Amplitude of the calibrator should be higher. Okay, in lower bands it's better. I will check the sensitivity, but I think now that the band switch is okay, maybe I have to relook to clean it again, the contacts. Now let's check the output power. Mode is CW. When I go to transmit and increase the carrier, we are on 10 megahertz. We'll come up to 100 watts. And this should indicate now the ALC, okay. And this is the, I see the current 6-7 amps. Okay, and the ALC, maybe this knob needs cleaning again. But there's also a relay which switches between receive and transmit measurement. Maybe the relay is a weak point and not this knob here. I'm not sure. On let's go to 7 megahertz, a lower band. Transmit carrier, we get 100 watts. But there we should have an ALC indication. Okay, here it is. Well, seems there's still some problems, maybe with a knob and maybe with a relay inside. There are 2 or 3 relays which need cleaning. Maybe these knobs need cleaning again. The pot, the AF pot is acceptable now. No, it's okay. It was better. It's better now. Well, that's the first step. The microphone connector is rewired. There was indeed one ground connection used to feed out the plus 12 volt from the power supply, and the only ground connection to the external world was the braid of the shield of the microphone. So it's not a good idea, because all currents are flowing over the braid, over the shield. This could cause some ground loops. Not a good idea. I rewired it into the original wiring now, and I'm curious what's this with the DFC, because there is also this 4-pole plug. Maybe if there's also a modification. Well, that's the end of part 1 of the videos about the Kenwood TS130S and the DFC230. A lot of cleaning was to be done. Now the ugly smell from the smoke is gone. The cigarette smoke or pipe, I don't know what it was. The smoke is gone now. Whenever you get such a equipment, you have to clean it outside and inside to wash it. The water was rather brown after cleaning the transceiver. Contacts were cleaned, maybe have to re-clean them again. The wiring of the microphone is okay now. We had a problem with this gear, with the screws, with the fixing screws. Bad bulbs, they were replaced. Now we are on a good way. Stay tuned, stay healthy. See you on this channel.